How does it look? Oh, the front. Good. Oh, is the PowerPoint version on the desktop? Oh, good. Okay. Sorry, everybody. First hybrid ever.
Nu ska jag se om så ska det vara nummer 2 på listan. Date modified. Så ska den ligga på topp.
Är den?
Den.
Okej. Does it look good? Oh, okay. So,
Online. Should I take it from the beginning?
no.
Okay.
They got the sound at least, and they will get the presentation afterwards. So.
Okay. So there are several scripts in this combined harvester. Then, like I just said, bash script, xquery, and xslt script. And for input metadata sources, we use OAI PMH feeds from Figshare. There is actually a feed which is already in METS format, although it's not complete. So that's why we have to transform it and also use the API to get the file metadata that is needed according to the FGS, the Swedish National Archives specification. It should be noted that the FGS is still valid, but it's no longer maintained and updated, and it will be replaced by the specifications on a European level by the DILSIS board. DILSIS is another abbreviation that I have to read from a paper, Digital Information Lifecycle Interoperability Standards. And it should be noted that one of the key architects of the DILSIS specification was actually with the Swedish National Archives before, and she's now at Sydarkivera, Karin Bredenberg. And what she did was to actually sell in this FGS to whole of Europe. So we're a bit proud of that, actually. There is an online version of all those files, but it's not been updated. I mean, the files of the combined harvester, the tools that we use, but it's not updated. So I hope to be able to publish a current version soon. These are the repositories that we curate in the research data management team, and of those, the Figshare institutional instance of Figshare is the one most frequently used. And as you can see here, it's not only for data sets, proper data sets, but also for reports and preprints and presentations like this, but it's the one most frequently used. So that's why we started by developing this combined harvester for that. I have another problem that I'd like to hide this. Yeah, it looks a bit strange here for me. But anyway, so these are the ingredients, so to speak, of the combined harvester that we use for Figshare harvest. And you can see that there are 5 different scripts and files that we use. And we start by with this list of the feeds that we download then. And we look at, I cannot move that. maybe. Okay. So this is the way we do it. We on the front page of the Figshare instance, we see the recently published items. And as soon as we have 10 or more new items in store that are published, we then manually update this list of URLs that represent the feeds that we want to download. And this updated list is then used by the first bash script to retrieve and download the new feed comprising 10 new items. And we use so it's very important that we keep the number of lines as they should be. So the script retrieves from line number 6 and 7, and then there's this manual step when we curl down to download the corresponding feed then of new items. So you see, this combined harvester is not fully automated. It has to be driven, so to speak, by a farmer or a human driver. So it's not like a robot lawnmower. After we downloaded this feed, it looks like this in our XML editor. And we then mark that feed, and since it comprises 10 new items, what we do next is that we use BaseX, which is a free software to download, to split it up into 10 items. That is metadata files, XML files, and these are then to be used individually to harvest also the data files. Since if we would have done this for all the feed at once, it would probably, or we know it would time out, since some data sets can comprise like tens or 20 or more files, and some data sets are quite heavy, up to at least 15 gigabytes. So this is the result of the split up done by this in BaseX, then with the XQuery script. And also you see here that at the same time we created a new file info XML file, although it's not well-formed XML yet. But this will be fixed with the next bash script. You see here before the use of the next bash script, it looks like this, but after we have renamed the file info XML into reflecting the current number of the URL representing the current feed. And also you see that we have created for each of these individual items, we have created a folder, a directory of its own, which is the base of the package that we intend to create. Next, we will be working alternately in BaseX and Oxygen, the XML editor. You should be able to use any XML editor for this, since Oxygen is licensed, but we found it quite useful to use it. But as I said, it should not be necessary. So we work alternately putting using these original metadata XML files with they are named with the DOI suffix so that they should be able to be retrieved by the DOI from archive later. And then after harvesting, then both the file metadata and the actual data files. In this case, there was only one PDF. And then this file info is then used as a parameter document for the actual transformation that takes place in the XML editor. So we use this transformation scenario that we created with the file info XML file and this is the result then, the difference between the original metadata here and the just created zip XML file that actually validates against the FGS schema, metadata schema. And you see some of the metadata that was added by means of this file info. It concerns the original data, original file name created by the author then, and the checksum, MD5, checkfile, and the MIME type, which we use a mapping table from the file extensions to create. It's not ideal since some file extensions can have multiple use, but we have found this to be most reliable actually, since we have control ourselves of this mapping table. So in summary then, what it does, this combined harvester, is to harvest data files and transform original metadata from several sources and repositories. And like I said, we hope to enlarge this to cover other repositories like Dryad. It's only semi-automatic. It still takes a human driver, a farmer, to run the combined harvester, but it prepares for long-term preservation in the local archive by enriching and transforming the original metadata to accord with the FGS. We are using only open, non-proprietary file formats for the scripts and in processing, while we use at least one licensed software, the Oxygen XML editor, for the actual transformation. While in Git Bash, we use it for Windows then, but you can use it for other operative systems as well, of course. And BaseX, this xQuery processor, they are both free to download. So thank you, and sorry for the interruption.
So it's a sorry from our side here for the technical issues that just disturb you from the important content here. So we have some time for questions. Maybe start with the audience here. Yes, at the back, of course.
Hi, thanks for a very interesting presentation. I was wondering, You said it's semi-automatic at the moment. Do you have plans, or are you seeing a future where it is fully automated? And if not, what are the hinders?
Yeah, I mean, this is still work in progress and has been for the last 3 years or something. But one thing that we have thought about is if it would be possible to integrate all these different parts into, for example, a Jupyter notebook. I have not yet found a way to do that easily, since as I have seen so far, XML is still not used so much in Jupyter notebooks. So, but if anyone has any ideas how to do this, I would welcome them. Please email me. And also there are other parts that could be more automated, like, for example, the splitting up. I have tried to find ways to doing that in the same bash script instead of in BaseX, but so far I've found that it's easier to do it in BaseX in the XQuery file. But I mean, there should be a potential here of making it more automatic. But I don't know if we can ever make it fully automated, but at least more automatic.
Thank you.
We're happy to take more questions.
Hi, thanks also for your presentation. I had a discussion the other day with one of our developers ourselves, and so I'm from the XML background, and he said if I would have to design sort of our archive again, and it wouldn't be XML based. He said we would go to JSON because it's much easier to parse and to serialize. And do you have any comments on that? How would you approach that?
Yeah, actually, I'm not sure I agree that JSON is easier to parse, but actually this combined harvester uses JSON. I mean, the file metadata that we retrieve via the API is JSON output, but it's automatically converted to XML in the XQuery processor in BaseX. Or automatically, but I mean, it's in the script. So it's, and I know that it's still, even the DILSYS board in their specification are still hooked on XML rather than JSON, although they say that we might do some changes there. But I, for one, since I'm an old XML guy, I still find XML easier to use and easier to overview and get the structure. I mean, you have to count all those brackets in a JSON file to see where you are, and so I don't agree that JSON is easier for a human to read, at least.
Thank you.
Okay.
Hello, thank you for your presentation. I would just continue to your question, actually. There are quite a lot of interface that are easy for humans to use, and then in the background, JSON is created. And also to follow up on your question, how you could integrate this with Jupyter notebooks. If there's JSON actually behind, and if you use pandas, it would be very easy for Jupyter notebooks to actually process and analyze data.
Yeah,
Thanks.
I mean, I've used pandas in other cases for processing CSVs and things. But well, it would take a considerable effort, I think, anyway, to use JSON instead, since this all started out in XML. And actually, it's sort of a heritage I brought with me from the National Library in Sweden, where we had this similar processing system for the handling the illegal deposit system. So I confess that I have some baggage with me from there that went into this. And when I started out on this, Jason was not that affluent yet, but who knows, maybe in the future, but it will take some effort to get there.
Okay, so thank you again, Joakim, for presentation.
Thank you.
You're allowed to clap again.
I don't know how to get out.
Yeah, sure. So thanks. We are going to the next presentation, and just as you have realized a little bit, and maybe also realized in the whole conference, that's a hybrid conference, and it has the potential to just double the issues you can have. So I don't want to jump there for online to live people. And if it's okay, I would readjust a little bit the order. And if Brian can maybe come up as the next one. So I will put the online presentation to the end, so we can concentrate on the different kind of topics at this time, different kind of issues at a time. So Brian Kleiner is from Force in Lausanne, Switzerland. He's giving a talk about collection bias in social science data archives, what's in and what's out. That's the question. He's head of the National Social Science Data Archive, as I told you, and he works interests in open science, data management, research infrastructure development. Just have to start the presentation here. And I hope you're ready to go. No, we're not? It's screen sharing. What screen sharing was stopped? Okay, sorry. Yeah, it's the best one. Yeah. Where is it? This one? This? No, that's not just him. It's better now. Thank you for all your help.
Sorry. Okay, thanks, David. I'm Brian Kleiner. I'm going to be talking to you about some work that we've done at Force, myself and my colleague Alexandra Stam, who's also here today, about bias in social science data archives. So just a word about the roles of data archives. I'm sure most of you are familiar with this in the social sciences, but not just. So in a nutshell, data archives solicit and acquire data, and they curate data, store them for the long term, and then they disseminate and make available these data for secondary analyses and publications and so on. One thing that maybe is less conscious for those who are operating data archives is that archives serve as a sort of gatekeeper in terms of what comes in the end. Often we have policies about what's acceptable, what's not acceptable, and this has an influence on, in the end, what is contained within the archive, what kinds of data. So there are filters from the archive side about what is acceptable, what comes in, but there are also filters from those who are producing the data and ultimately at least trying to deposit them into archives, that is, filters from researchers themselves who are making decisions about whether or not they want to or are able to submit their data to data archives. Sometimes they're not able to, sometimes they're resistant to this. More and more they are pressured to do this by science funders who are requiring this, or sometimes from journals. So from these two sides, from an archive perspective, from the researcher perspective, this may lead to what we are calling a form of bias in terms of what is actually contained in the end. And what does bias mean? It just means in the end, certain things come in and other things do not. And this can be systematic in the sense certain types of data might come in on particular topics, on particular populations, and others might be left out for different reasons, which makes them kind of invisible. And it's my impression that at least within the social sciences, there hasn't been a great deal of reflection about this question of bias. So we all basically we operate our data archives. We have certain policies. We have the data in it. We make it available. But from what I've seen, from my personal experience and also from the literature, there's very little institutional introspection about this issue. So we decided to do some introspection within FORCE with regard to our National Social Science Data Archive. And even beyond introspection, we decided to do some empirical analyses to find out what's going on and whether or not we actually do have such biases. And if so, what is the nature of those biases? And then beyond that, well, what are the implications? Implications for secondary analyses, implications for science and social science more generally. So those are our questions. And in order to address those questions, we embarked on an internal assessment first of our own policies. That is, what are our own filters that lead to decisions about what comes into our archive and what are our practices. And basically we spoke with our archive staff to see what they're doing. You know, how often is it that they refuse, for example, submitted data sets from researchers and so on. Basically what we found is that we refuse almost nothing. Researchers do enough filtering themselves so that when they do come to us, it's basically stuff that we can accept because they've already looked at our policies. They know that we don't accept data that are not anonymized and cleaned and well documented and so on. So from the archival perspective, okay, we have a certain policy that forms in itself some level of gatekeeping, but we are not actively playing an important role in filtering in general, especially because in Switzerland, we basically are required to accept all social science data as part of our mandate. So we cannot just say, well, we don't really like your study. We don't think it's high enough quality. We basically have to take what we get, you know, provided that it's, you know, doctoral level or above. On the other hand, we wanted to look at researchers' filters and practices that might lead to bias. And in order to do that, we had a look at what we call our research inventory. So just to give you an overview, within FORCE, we operate not just a data archive, but we have a larger database, which includes about 11,000 project descriptions. Most of these projects, it's fairly rich metadata, but for most of these projects, there are actually no data sets linked to them. So these are just project descriptions. submitted and published from the researchers themselves, we have about 11,000. And of those 11,000, we have about 400, about 4% that actually have data sets attached to them. So what we decided to do was to get in touch with researchers, PIs, principal investigators of projects that were published into our system, but where there were never any data published. So we excluded, in fact, the 400 projects where we actually do have data. And we asked them through short, qualitative, in-depth, well, fairly in-depth interviews, well, why didn't they deposit their data with us? So they knew about us, they took the time to publish their project descriptions, but in the end, for one reason or another, they didn't submit their data with us. We limited our sample to projects that were not too old, so those that were completed between 2015 and 2020. And then we sent out customized emails to 1,236 PIs of those projects, and in the language that these projects were documented in our system. And so this was either German, in French, or in English. And in the end, we got back 362 email responses, 95 of which basically provided us with an answer. So they said, well, you don't really need an interview with us. I don't have time, but I can tell you that we didn't deposit our data with you because X, Y, or Z. So we had some information already in these 95 written responses. And then we also conducted 40 completed interviews by Zoom, either in German, in French, or in English. And what we did with all of these results, either the written results or the oral results through the interviews, were to do some coding. So we created a coding scheme, which is fairly exhaustive. So this covers all of the reasons that we received through the written explanations or through the interviews. And well, I hope you can see this from the back. Basically, it ran the gamut. In many cases, they just told us, well, our project actually didn't have any data. So no original data were produced. In many cases, they used secondary data, which would mean that, well, there were no data to share of their own. So that was one of the codes. So some of these you'll see anonymization problems, contextual issues. So researchers who would say, well, nobody could understand my data because they weren't there in the production of the data. And they couldn't understand the context, so it wouldn't make sense to do it, and so on. But I will skip to the next screen because here are the same codes, but regrouped into different larger categories. So the categories that we came up with basically are data protection issues, which included anonymization, people who said their data were too sensitive, people who said that they didn't get the proper informed consent, or general ethical issues which prevented the sharing of the data. Then there were quite a few who claimed to have certain practical barriers to sharing their data. So they had limited resources to prepare their data for deposit, limited know-how for being able to make their data shareable, not having the time, lack of documentation. And then the third big category was data sharing rights. So these were cases where these were international projects, and the researchers didn't feel that they could deposit data in a Swiss archive where these data might belong to a larger group across national borders. Quite a few cited copyright issues, rights to disseminate data, and so on. And you can see some of the other reasons which were more difficult to categorize. The numbers you see there are just that. So these are numbers out of the 135 projects for which we have information. And then on the next slide, what you see are percentages rather than numbers out of the 135. If it makes sense to even quantify this, but it gives you, an overview of what's going on. But I can summarize a bit what we have here. Actually, this was another slide where basically we excluded cases where there were no data used or only secondary data, where the data were actually already archived, but elsewhere, not within our archive, or where they told us that the data would be deposited with us at a later time. So if you exclude those three categories, it changes the percentages, but it's not really a meaningful or interesting difference. So let me go to some initial observations on those results. So first of all, the PIs of 33 of the 135 projects just said that they were opposed to data sharing in principle. And all of these because of contextual reasons, where these are the ones again who said, well, nobody can understand my data. You had to be there to really appreciate and make use of these in a meaningful way. On the other hand, one of the striking results of our findings was that most of the people that we heard from were very much in favor of sharing their data. So it's not in most cases because they don't want to. It's more for other purposes, which you've seen already. Another important observation is that it's not just data protection issues which were preventing the sharing of these data. It was equally practical constraints which were preventing the sharing of the data from these projects. Another observation is that there was quite a lot of diversity of reasons for not sharing the data. You saw that in the codes. And most PIs of sort of these eligible projects professed actually more than one reason. So they would not just claim one particular reason, but usually many for why they couldn't share their data. And finally, in the vast majority of cases, the non-shareable data were qualitative in nature. And probably that's not surprising to most of you who have experience in this domain, but we're going to address this in a moment. So regarding bias in the FORCE data archive, you might think of your own archive if you happen to work in one or in a repository to see if this rings true for you. Data that are, in general, sensitive or involve challenges for anonymization and informed consent are generally less likely to appear in our data archive. These are usually data that are produced using qualitative methodologies and from projects that target smaller samples and possibly more vulnerable, harder to reach populations. And in parallel, data that require more effort or resources for sharing may be less likely to find their way into our archive. And often these happen to be qualitative types of data. One other important finding, I don't know if this is the case everywhere, but nearly all of the PIs who invoked this context reason for not sharing data, these were, without exception, ethnographers. So this is clearly a disciplinary issue, tradition. So most of them also cited multiple data protection issues. So it wasn't just the context issue among the ethnographers. So data from this discipline also are less likely to appear in the archive. So I'm coming towards the end. Some early conclusions. All of this confirms what is probably not surprising to most of you, that there's a bias in the Forest Data Archive. It might be that there's a bias in others, and that basically data which are easier to share for one reason or another are in our archive, and that means quantitative data. So we have almost all quantitative data with some qualitative. And we think that there are implications of this bias with respect to secondary use, but more generally with respect to science. It means that sensitive data on smaller, more vulnerable populations, possibly from less well-resourced projects, will tend to be out of reach for future use. So it means that quite a lot is effectively invisible to science in terms of potential for reuse. And we need to probably reflect more about what this means, and also perhaps be more transparent about this with our user communities, so that they're also aware of what we have and what we don't have. And finally, I'd just like to note some next steps within FORCE. So we also would like to do some quantitative analyses, because we have a lot of rich metadata at the project level, also at the data set level, which could help to maybe shed some more light on this question of bias. And then we also, of course, we want to take what we've learned and to identify and then implement possible remedies to correct some of these biases, including creating written guides, trainings, and so on. But knowing full well that what we're up against to a large extent is really a culture of non-sharing, which is extreme among ethnographers, but it's also still common in many other social science disciplines, which are always going to mean that certain data will get shared and others will not. And we have to live with it to a certain extent. And then my final, two final points. One is that we also want to look at the users, those who are actually using our data, to see what they're actually doing with the data. Most of these data that they're using are quantitative, but some are still using qualitative data. So it would be interesting to speak with them and see what they are actually doing and what their needs are specifically. And then the final point that I'd like to make is that it would be nice if this resonates with those of you who are operating within archive environments, to reflect on these questions yourselves, to see if the same holds true in your data archives, and to think about what it means for you. And so if this could be scaled up to a higher level, that might be interesting. So I believe that's all. Thank you.
Once again, we're happy to take questions.
Hi, thanks, Brian, for a very interesting presentation. I'm one of those targeted in your last bullet point, working in a social science data archive in Finland. I would be definitely interested to sort of see if we could scale up and see what comes up. My question is, did I get it correctly that FORCE as such, do you see that you have like appraisal criteria that would also work towards a bias in what is taken in or what you can process? Because if you think it from the, let's say, the certification point of view, where you sort of make promises to your designated communities that this is what we do and this is what we can do, that tends to lead sort of you excluding those you can't serve. So I would say that is something that you can't then solve, but you would have to sort of work on a larger national or EU or international level to make sure that there are other actors that can do what you choose not to do or cannot do.
Yes. Yes, thank you. Yeah, in terms of appraisal, we have our acquisition policy, so we define for our user community what is acceptable for us. We do appraise quality, but usually quality of documentation, quality of the data themselves, but usually this gets worked out with the researchers. So if we receive something that we find unacceptable for one reason or another, usually we can go back to the researcher and say, well, we really would like for you to clean up the data or better anonymize the data or provide additional documentation. And so that usually does get straightened out. And as I said, we tend not to refuse any of the projects. It's true that there are other systems that are available to users in case they feel that they cannot do what is needed to deposit their data with us, so they can go and deposit their data on, for example, Zenodo, which is much easier because there's no one to check. You just upload your files, you add a little metadata, and then you're done with it. And many researchers go there for that reason, because it's very easy. So those are the ones probably who fell into our category. We deposited our data elsewhere. So yeah, I hope I answered your question. Okay, thank you.
So then, thanks again for Brian for the presentation. So we prepare for the next one.
It's already shared on Zoom.
Yes,
Okay.
we didn't stop this time. All right, so next presentation is about the Japan Data Catalog for Humanities and Social Science. Presentation by YUKIO MAEDA. He is a professor for political science at the Interfactually Initiative in Information Studies and Institutes of Social Science at the University of Tokyo. He earned his PhD in political science from the University of Michigan in 2001, and he specialized in electoral behavior and public opinion. He is a member of the Social Science Japan Data Archive from 2006 to 17. And while he's still doing research at the University of Tokyo, he also serves as a project officer at the Japan Society for the Promotion of Science since the beginning of this data infrastructure in 2018. The floor is yours.
Thank you very much. Okay, hello. Today I have a limited number of flyers like this, which has a QR code, and a young gentleman from Japan over there can distribute it if you want it, and just please raise your hand. He goes to your place for flyer, and I will try to make my presentation quick. Okay. I'm a political scientist, but in the past 4 years, I also worked as a program officer at the funding agency, JSPS, to promote research data sharing in Japan. While working on this project, I have, on many occasions, I received encouragement and advice from the friends at the European Data Archives and elsewhere. So I feel really obliged to make presentation of my progress or lack thereof. Okay. Sorry. And I have two co-authors who are not here, unfortunately. They are responsible for technical aspect of this project. Okay, I want to next. Okay, this is overall outline of today's presentation. And first, I will briefly mention the policy background. Then I will give you an overall picture of our data catalog, which is called JDCat, which is an abbreviation of Japan Data Catalog. Third, because JDCat is a catalog which harvests metadata from the 5 organizations, I will briefly explain the contents of the data available through the JDCat. Fourth, to develop such a catalog, we have to define a metadata scheme to make it interoperable. So I will show part of our metadata scheme. And in the end, I will say a few words about the future of the project. One reservation is that actually I have something to say about social science data sharing, but my knowledge on the humanities is limited. So I primarily focus on the social science aspect of the data and the project. Okay, I think I will just skip this slide. So I will just directly go to the general overview of JDCat. JDCat is a catalog which harvests metadata from the 5 organizations listed here. 4 of them are in the domain, working on the domain of social science. 1 is in the domain of humanities. And for the 4 data organizations in social science, they each they received data from researchers and made and prepared documentation for their catalog. And this institution is slightly different. They are specialized in historical materials, so they do not take data from researchers, but they take data from something like temple and notable families from 200 or 300 years ago. And they prepare metadata, and their metadata are harvested to the Japan data catalog through OMI PMH. And through Japan data catalog, people or say researchers or students can search data set across these 5 institutions. Sorry. Okay. So yeah. For social science, we cover most of the survey data available for secondary analysis through JDCat, but the scope of the data in humanities is limited at this moment. And next slide. Okay. I would like to explain our objective by making a contrast between before and after the introduction of JDCat. Before this project, there was no single point of entry or portal site that helps data discovery in social science in Japan. Now we offer a single point of entry for data search across the data centers. Second, before this project, we did not have any standard in metadata in Japan. Each organization was developing its catalog independently without reference to each other. Now we somehow force them to use the standard metadata scheme in order to achieve interoperability. Third, we asked each data center to make their metadata bilingual between Japanese and English. I believe the combination of single point of entry and metadata in English makes a huge difference for international users interested in Japanese research, social science data. Now I would like to say a few words about the technical and formal aspect of JDCat. JDCat is developed as an open source program using the repository software called WECO3, which is a Japanese software, and I will explain about JECO3 in the next slide. JDCat harvests metadata from the 5 data centers, either through OAI PMH or resource sync. And social science data center prefer to have OAI PMH, but one in the humanity prefer to have it through resource sync. In order to promote data discovery or let the metadata travel further, metadata in JDCat are published under CC0 license. So its metadata can be harvested to the other catalogs without legal difficulties. We also require each data center to assign DOI to its dataset. Then what is WECO3? Actually, WECO is, I think, it means repository in Swahili language as far as I learned from them, but I'm not entirely sure. WECO3 is itself an open source repository platform designed for Gyro Cloud, a Japanese repository service We customize the existing platform to build JDCat because WECO 3 is flexible enough for our purposes. More specifically, I think WECO 3 allows users to customize the submission and dissemination workflows and to manage metadata flexibly to sub-specific needs and standards. And it is possible to harvest and provide metadata through OAI, PMH, and resource sync. Okay, this is an actual interface of JDCat, and here is also screen on QR code, which can also lead to the actual interface. And I have already uploaded the slide onto Zenodo. For those who are viewing this presentation remotely, can download the file later. And at the upper right corner, here in this red circle, you can switch language between Japanese and English. And typing keywords here, I just typed life cycle, then click hitting this search button, then it provides a search result for life cycle. And you can filter the result using the facet menu on the left side of the screen. And by clicking the title, it leads to an individual record of metadata. Okay, then this is the actual record. Though we have an interface in English and in Japanese separately, somehow metadata in the two languages are displayed on the same screen. So we have interface in English and Japanese separately, but in the both interface, essentially we show the same metadata in two languages. It's a long story why we did in this way, but I think my colleague in the humanities made a strong case that we have to have the multiple language on the same screen if you are serious in the historical studies. This is what his argument. So we made some compromise. For contemporary social scientists, it's more makes sense to have two languages separately. And then, because JDCat is a catalog of metadata, it doesn't have data, it's the data file itself. So to get the data, you have to click this URL and then move on to the actual website maintained by each data center I mentioned in the previous slide. Okay, in this slide, actually, it's too many words on this slide. This table shows how the 5 data center maintain their connection to JDCat and Gyro Cloud service, and the types of their main data holdings, and the number of data holdings available is listed in the last column with header N. I will explain them in detail, but 3 data centers, 3 data sets in the upper 3 rows are more or less traditional survey research center with its survey archive division, even though SSJDA, which is in the middle, is far larger than the two others. Currently, I think roughly 200 data sets are available through JDCat from SSJDA, but they have more than 2,000 data sets, but they only provide metadata at this moment for roughly 200 data, because I think they have to prepare metadata in Japanese and English, which are not specified in their local catalogs. So they are working hard to increase the number of data sets available through JDCat. The 2 data centers, bottom of the 2 data centers works. Business model their business model are so different from the upper 3. To some extent, they are dealing with the first one deal with historical tabular data from the government, and the last one deal with historical documents. So depending on how you count, actually they have more than say hundreds of thousands of data or record. So, and they are also working on to increase data or metadata which are available through this metadata catalog. Okay. Then to make our data set, our data catalog work, we have to set a metadata scheme. And the metadata scheme is based on DDI codebook. To set this metadata scheme, we consulted several catalogs of large data archives, and essentially we picked up most widely used elements for our data catalog. And so actually, by using DDI codebook, we thought at least it makes interoperable, or the metadata interoperable to the data archives in the foreign countries. But also we want to make it interoperable to the other data catalog or say repositories in Japan. So we mapped the metadata scheme onto the JP core metadata scheme for crosswalk. This is a Japanese original metadata scheme for institutional repository. Then this is actual list of metadata elements. I will not explain it. People in this room know far better than I regarding what it means. But we have 5 minimum required elements and 11 strongly recommended elements and 3 recommended elements and 12 elements not listed here is just as needed. You can enter. And 8 elements in bold characters we enforce controlled vocabularies. And this is actual example of XML file for particular record. I am not sure whether it is worth interesting for anyone in this room, but as a metadata in Japanese and English are described in the same single XML file. So rather than having 2 XML files, one for English and one for Japanese, we decided to have it in a single file to make at least management easier for the control purpose. And then, but for those who are working on the data or metadata, do not have to know the details or mechanisms of XML files or metadata scheme. We provide us an easy metadata editor through Weko3 system, so they can just type in. They can just type in what they want to type, and also they can. And for the control vocabulary, we provide pull-down menu here. And I don't think you can read it. It says Sweden in Japanese, and it's here is Sweden in English. Okay. Finally, this is a list of controlled vocabularies in the JDCat system, and we tried best not to create any controlled vocabularies anew, but unfortunately we have to create one for data type, which I think. Because of our tradition in social science, we couldn't avoid creating one, but at least the rest of them we have just borrowed from somewhere. And 4 of them, 3 of them are from the DDI controlled vocabularies, and one of topic is from CESDA topic classification. We translated them into Japanese, and 2 of them are already registered at the CESDA vocabulary service, and 2 of them will be registered by the end of this summer, I hope. Then I have to do it by myself. Okay, this is a last slide of mine. And okay, this is the last year of our funding period. Then what's next? At least for the next several months, we want to make more data sets and records available through the JDCat and the data centers to at least try to appeal to the, say, decision makers or government. This project is worth next phase of funding. And for this level of project to keep operating, I think continued funding is necessary to keep qualified professionals to work on the data and the metadata. And including myself, actually, I'm working with say government officers to prepare a document, policy document to convince the Ministry of Science and Education to provide funding for the next 5 years. And I am not entirely sure, but we are going to hear about the result by the end of this calendar year, I think. Then what happens if we get the next phase of funding? What's the next phase? Actually, the who will manage the JDCat and its metadata schema, and which data center will receive funding to do this kind of work will be decided through an open bidding processes. I am not entirely sure whether, say, repeating, say, open bid for every 5 years for data infrastructure is a good idea or not, but this is the only way our government allow us to select the institutions. So I am hoping we can get another round of funding, and I hope someone else will be presenting the next phase of a project several years later in the IASSIST conference. Okay, that's my presentation. Thank you very much.
We can take 1 to 2 questions, maybe. Not too long. Please.
Thank you. That was very interesting and helpful. My question is about the metadata around your access categories in particular. And I'm curious if the research centers already had a standardized set of access categories like open, restricted, or sensitive or something, or if you had to nudge or encourage or force them to adopt a harmonized set of access categories as part of this project.
Actually, I think that my answer is that I think each data center, at least for the 3 data centers, had their own categories, but fortunately they are similar enough from the beginning. A part of the reason why I said Social Science Japan Data Archive is the first one who started this kind of data service in Japan, and the following 2 organizations simply actually mimicked or imitated the category which SCADA provided. So my answer is we kind of forced as a new schema or as a control vocabulary for this data catalog, but the control vocabulary we set is not in contradiction. Not in contradiction with the existing rule adopted by the 3 data centers.
Thank you.
Okay, good. So thanks again for the presentation. Now we have to change modes. So I'm getting out of this, and I think hopefully in the audience, Jean Wang from Roper Center is already there. Maybe you can unmute his mic and say hello to us. I stop sharing here.
Good morning. Can you hear me?
Yeah, perfect. So maybe you can also share your screen and slides then. Looks very good. I think I keep it like that, and we can see you, we can see us, and we can see the slides there. So just a short introduction. You're currently the lead engineer at the Roper Center, having joined the center in 2016. Jean is responsible for coordinating and planning technical projects at Roper, as well as designing and implementing software systems to support the goals and visions of the center. Prior to Roper, Jean spent 3 years as developer and technical lead at software company in the retirement industry. He currently holds a Bachelor of Science degree in Mathematics Computer Science from the University of Buffalo, and he can introduce his talk now, and yeah, floor, kind of his online floor is yours.
All right. Thank you very much for that introduction, Dave. Good morning. It is morning here in New York. As David said, I am the lead engineer here at the Roper Center. And so this presentation will be from the perspective of the engineering team, and it will be on the custom software that we have built and will continue to maintain for managing the archive here at the Roper Center. For those of you who are unfamiliar with the Roper Center, we are the world's largest archive of public opinion survey data. Our archive contains currently over 42,000 surveys from all over the world. And it dates back as far back as 1935 until the present day. And we, as a center, moved from our previous host institution, which was the University of Connecticut, to Cornell University back in 2016. And during that transition, we only inherited 2 staff members with the center. So what we got were the systems, the data, and amount of documents, but not many people. And since coming to Cornell, we have built up a small but effective engineering team. And for the past 5 years or so, we have spent the vast majority of our time improving and modernizing our technical systems, which include both applications for our end users and the researchers we service, as well as tools for our internal staff. So this presentation will be to share some of the experiences from us. We will be focusing on 3 main areas today. First of which is the data and how we manage, process, and disseminate that data. And we'll sort of set the stage by going over our archival process. And then next will be an overview of the design choices we made, along with some general philosophies that we adhere to, as well as principles driving and influencing those decisions. And lastly, we'll take a look at the end results in the form of our software systems, as well as some supporting tools for the archive. So with our primary function being an archive, the core process we have is fairly straightforward, which should be familiar to anybody else working in an archive. And in 3 general steps, first, we take in data both passively via a handful of different channels. People send us data via email, SFTP, or through our web portals. And we also actively fetch publicly released data from other polling institutions. Once we have that data, our data curation staff then processes the data and as well as archives it. And finally, we make that data available for use by the members at our member institutions. So pretty easy, 1, 2, 3, and we're done. And unfortunately, as they say, the devil is in the details. So we will take a closer look at the middle step, which is curation and archival. And this diagram is an excerpt from our internal documentation, and it primarily deals with the main portion of the data curation process. So that, as highlighted in red, is the middle step. And in this diagram, each box represents a possible state for a survey to be in as it makes its way through our systems. For the transition lines between those states, the green ones are handled by an automated system, and the red lines are manual transitions requiring handoff between actual people. And I'm not going to go through all of this in detail, but the 4 items in the main horizontal axis, which are awaiting ingest, processing, QA, and published, are the clean and simple route of a survey as it goes through. So comes in, gets processed, and it goes out. And all of the branching paths are when things deviate from the normal. So for instance, if a survey is being rejected because it does not meet our acquisition policy, it goes into a rejected pile. If there is an error in a published study, it goes through our error correction process, and so on. And similarly, from our documentation, we have a life cycle, sort of a hybrid state diagram and data flow diagram. And this describes the path a file takes as it works through our systems and goes into the archive. So again, not going to go through everything on this slide, but I will point out that part of our design is that as a file enters the archive through the ingest applications, it is stored in an isolated staging area that is the top center part here, which is entirely separate from the archive proper. And we also have a single point of entry into the primary copy of the archive, and that is by design so that we can secure the archive and do not allow access by either people or other systems. And after it makes its way through, multiple copies of these are stored in separate geographic locations, one locally here at Cornell University servers, and multiple copies in the cloud, and mostly in Amazon data centers in the United States as well as in Europe. And several parts in the middle are for scanning the entire archive by a custom-made application to check for data integrity. And we do that by computing the MD5 checksum against all the files and validating that against our records. And in addition, we do the MD5 checksum computation every time a file moves between systems. So in the course of developing those processes, as well as our systems to where they're now, we have come across a number of challenges. And here is a brief list of some of the notable ones. So in trying to design our systems, we've had to handle the complexity of merging data. So in our particular case, we have portions of a single survey enter the archive through separate data streams. And our response to that is to try and to make that merge process systematic, as well as design our workflow to minimize those occurrences. And regardless of how we attempt to make large-scale batch data processing as systematic as possible, every instance we've had to deal with are still extremely time-consuming as well as resource-intensive. As such, we are open to ideas on how to make these more efficient, but as of now, we just sort of have to eat that cost. We have also come to terms with the fact that our incoming data is messy. Our data providers, for the most part, do not adopt to some of the industry standardization. So we don't get a lot of data in things like DBI format. So the best that we could do is to actually isolate our external interfaces and minimize all of the impacts of those differences. Similarly, we also found that errors and anomalies are sort of the norm rather than exceptions. And as far as we can tell, whenever we try to make a rule, it comes with a handful of exceptions. So we've had to build a fairly flexible system. And the best that we can do in that case is to design the system in a manner to help mitigate any source of human error. And lastly, we found that, as indicated in that highly complex diagram, trying to enforce multiple workflows is very difficult to do via software, and especially trying to do that in a cost-effective way. So in the end, what we have done is, as denoted by those red lines in the diagram, delegate much of that to human processes and decision making. So in response to some of those issues, as well as having developed our system sort of in parallel with the growth of our data curation side of the house, we ended up with this general set of factors to consider and in priority as it comes to systems design. So here are what I would consider to be our top 5 things. The first of which is data integrity, meaning that our design must always align with the primary mission of the archive, which is data preservation. So anything that goes against the maintenance of data is definitely a no-no. Secondly, we prioritize system stability in the sense that having an old thing that is functional is better than having a new thing that's broken. So to help with that, we have continuous integration systems in place as well as automated testing. Next one is usability, and we, at the very end, our system is a tool for its end users, so we make sure that we consider that. And as a small organization, we also consider the scope of our projects. And lastly, single source of truth is something that we've come to, is an oddball here, but in response to having our old system rely on a complex set of synchronization things, which led to the archive being out of sync as several hours a day, we have designed it to be in this manner. One thing I would like to point out is that when it comes to documentation, we have learned to document why over what. So as an archive, we have to think in the long term. And what we have inherited from our predecessors have a lot of documentation but they were documenting how things are and how they were built. But what was missing from us was their decision making. Why did they do things in a particular way? So in essentially trying to reverse engineer much of these systems as we try to improve things, it was difficult to gauge their original intent, as well as trying to make some informed decisions on what to change and what to keep. So the output of all of that is some of our systems. One major piece is our core data model, and that takes the form of a couple of relational database schemas. And it is designed as a streamlined and optimized version of the database that we inherited, plus a number of DDI-inspired elements, including some of its control vocabulary as well as actual structure, and also the support for brand new structures attached onto it. This is a pretty rapidly evolving model, and we have built and improved our systems. And in the past 3 years alone, we have made 250 plus updates to that model. So in order to maintain compatibility with external standards, we actually built a dedicated data translation or conversion module so that our core data model will be able to map to things like DDI Dublin 4 and the JSON LD format that Google Dataset Search takes. So we can remain compatible without having the external standards impact our own development of our data model. We have also developed a fairly robust DevOps system for software development here. All of our source code is version controlled via Git, specifically inside Bitbucket. We are pretty much an Atlassian house here, so we use a fairly broad range of their tool sets, including Jira, which we use to catalog all of the changes, the bugs, and everything to do with the code. So again, our documentation of why over what includes putting those decision-making information and rationale inside all of these Jira tickets, which are then linked directly to changes in our source code. In addition, we make use of Confluence as an additional repository of documents that are not necessarily related to the source code itself. And finally, the major software outcome of all of this is our own internal custom-built archive management system, and that our staff have affectionately named Elmo after our the founder of the Roper Center, Elmo Roper. And as the node diagram on the right indicates, it is responsible for a significant portion of the activity at Roper, in addition to data archiving. And many of these functions have been put into the system gradually in a modularized fashion, which allows us to both be able to change and replace parts of the system without impacting the core platform stability. So while the primary feature of our archive management system obviously is for data archiving, many of the supplemental features are very much also critical to the archives function, such as account management for our membership, as well as usage reporting and things like that, all of which is beneficial to have centralized, again, into a single source of truth that is being managed by this system. So knowing that this session ends on schedule at 9, I try to be quick with my presentation. So that is the end of it. My email is here, and I'm happy to talk to anybody who wants to chat about general archiving and software development. Thank you.
So thank you. And maybe if the audience is a bit patient, we can make 1 or 2 questions, maybe, just because of the accidents we had at the beginning. Is there anything? Coffee will still be there, I guess. All right, so coffee wins over questions. But again, thanks to all for the presentations we had. Maybe a last round of applause and then enjoy your coffee session. And thanks to the presenters. Yeah, thanks, Jean. Yeah, go ahead. So what do we have to do? Stop it.
We have to press end and choose leave meeting. Don't do the all one. Yeah, so press end, leave meeting, not yeah. And then video will be recorded and saved. You can just assign it to me. Just assign it to me.
Okay, assign.